Hello, everybody. Good morning, good afternoon, good evening in my case. Well, in this case, we are to we're ready to discuss briefly um, the emulation of the updated CANARIE backbone network topology under IPv6 up to 2022. This paper is the number 3162 for the International Conference on Electronic Communications and Networks. Well, my name is Ignacio Castillo, and we work for the Autonomous University of Mexico City. We're at the Advanced Networking Laboratory at the same university. Well, briefly, I will talk to you about advanced networks, backbone, internet, and network management. In this paper, briefly, I will begin with an overview for advanced networks. Then I will talk briefly about the methodology, results, and conclusions. In this case, I will put two very interesting points to consider. One is that the internet service providers maintain high secrecy for Internet 2. This is the case for the advanced networks, or what we call the National Research on Education Networks. But even more, the secrecy is even more for the commercial internet when we are talking about the backbone topology. So it's a kind of a secret in general. But we have, in general, public the backbone topology for the advanced networks. But due to the internet one, it means the commercial and the advanced networks are around the world in an infrastructure very similar. It means in switching, routing, optical fiber. So that's the point. They are very similar. So if we understand how advanced networks works and how is the network, the backbone topology, we can have a close understanding about how is the backbone topology of the commercial internet. So in the second most important point is that maintaining and updating for Internet 1 and Internet 2 and the infrastructure is very important. Mainly in this century, everything is supported by the internet, no, and the infrastructure of internet. So mainly at the backbone level. So well, even around the world, IPv4 is very well known and very well implemented. But since 2012, the main internet service providers began the transition to the version from IPv4 to IPv6. But this transition is not completed at all. Well, in this slide, we are checking that, well, we have advanced networks since 1996 till today. In this case, we can see, for example, Internet 2 for the United States, GIANT, the Gigabit European Advanced Network for Europe, CANARIE for Canada, APAN for the Asia Pacific countries, Clara for the advanced networks in Latin America, Africa Connect, even in the project number, the version number 1, number 2, and number 3. But also we have some others, some other advanced networks I wish to remark. In this case, we have the CERNET for China, RUNET for Russia, and ERNET for India, for example. No, well, in this case, we have a huge number of people, of researchers from China. So I will offer briefly the example. For example, okay, well, for instance, in this case, for China, we have the China Education and Research Network. It means the advanced network used by China. In this case, we talk about the China next generation internet. We have the topology, the backbone topology at the left with bandwidth, maximum bandwidth of 100 gigabits per second. And well, at the right, we see a picture indicating the transition step uh, step by step from IPv4 to IPv6. In this case, we have a specific project named CERNET 2. Well, there is a specific document where there is the analysis of the implementation and development for the transition to IPv6 for this CERNET. And in the case of China in general, the project indicates that everything will be completed and at the year 2030. But well, in this paper, we're specifically focused on CANARIE. It means the Canadian Advanced Network, or the Advanced Network for Canada. Well, our interest is to study CANARIE. CANARIE has also, we are talking about the backbone. We are centered to study CANARIE, but specifically about the backbone topology. No, in this case, this backbone topology is composed by around 28 backbone routers, but let's put a view in past. Now they have in Canada 13 provinces and territories. And well, how is it this advanced network in Canada after 27 years of being created? Well, they are also moving in transition to the IPv6. So what we want to do is to recreate using emulators of how this kind of advanced network works. Well, they began to implement this in 1990 till 1997. It was the pre the pre-internet 2. It means this is what we are watching here is the backbone for the internet, which changed to be the commercial. And it means the pre-1 to commercial one, it began with 10 backbone routers. Then the CANARIE began in 1997 in this case. And even after 1998. Officially, CANARIE is the advanced network for Canada since 1998. It changed the infrastructure from 1 gigabit per second till 100 gigabits per second, similar to the infrastructure that China, for example, has. No, well, we have here the topology, what we call CANARIE. But for this word, what I want, well, if we talk about real equipments, these real equipments are very expensive. No, this is the backbone equipments. They could be very close to 100, half $1 million, $1 million, or $10 million, or even $25 million. The backbone equipments. So if we are in the academic world, it's impossible for us to have a clearly and close relation with equipments, the backbone equipments in the production environment, which is really managed by the ISP companies around the world. Well, specifically, what we do in the academic world. In past, I worked for Telmex, a huge company for Mexico, but also it controls telecommunications in Spain and in Latin America. And well, what we do here as academic is to use emulators. Also, for the GNS3 emulator, we use Wireshark, iResonance, Meet Browser, VirtualBox, and Kali Linux, but it could be any variable. So the idea is we have very expensive equipment, and what we have to do is to use emulators. Well, which is for the methodology. We try to emulate the connectivity and then the management for all the elements in the backbone profile. So if we see here the figure in this figure one, well, this label is related to what you will find in the paper. So we have the backbone topology for CANARIE in till or up to 2022. They have 28 backbone routers. In this case, for example, we use the C72, the Cisco C7200 family mapped to GNS3. We use the iOS original and put it to run. And well, we have some addresses in IPv6. Uh, the newest router they have updated is the Nunavut. It means at the center, north and center of Canada. Well, that's the backbone topology. So obviously, it could be considered as critical infrastructure. It connects universities and research centers. Well, in this case, what we have done, we repeated for each of the routers the configuration for IPv6. For example, IPv6 router OSPF 100, the area, the numbers, all the uh, configurations in interfaces for each of the 28 backbone routers. And then in the part of methodology, we checked how to implement the network management systems, the means, the agents, and we did the configuration for the SNMP server activating each agent. Then we did the configuration, all including traps at the end of the day, including for the version 3, SNMP version 3, the authentication, which uses MD5, for example. Then, well, some results. We tested connectivity. Yes, I know it's very easy when you use ping, but it's a kind of procedure. We also did the verification of all the IPv6 packets using OSPF in version 3 for IPv6 packets. We used the Wireshark, all the interfaces, we tested some downlink actions in order to generate the traps using the downlink and uplink, and well, the trace route. And well, what we found is that the average latency was around 10 milliseconds, so it's really very close to the real to the real conditions. Not too much differences. And well, I will indicate at the end the two main problems that emulation can offer. Well, we did also management tests, and we used 5 kind of tests: the sysname, if number, if table, the address table, and routing table. We have this in this case. Well, we asked for the name in the case of Nunavut, and after we try to get the interface. The state of the interfaces and all the data for interfaces in that router, and well, we got this on the me browser. No, well, we also obtained this the specific data related to IP address table in order to get the specific details. And then we also did it for the routing table. Everything was verified. Well, so in order to end on time, the conclusion, we tried to make the replication for the real backbone infrastructure, just like CANARIE. It was emulated with no problem. And well, we have to remember that we used an i7 Intel CPU with a 16 giga bytes of memory RAM, and it was used at the 90% of the RAM and 30 to 42%. When we tested connectivity, we had 30% in CPU and in the RAM it was 90 for all the cases, but for management it took a bit more percentage, 35 or 42, when you ask for bulk tables, no, about the usage of the CPU. The average latency measured for all the connectivity around 10 milliseconds. This is interesting how we studied how it works, this advanced network works, and we are collecting evidence for GNS3 development group to improve some characteristics. The main limitations that we can find for GNS3 is that they use 1 gigabit per second as the highest bandwidth, when in some cases the real infrastructure uses 100 gigabits per second, and maybe the limitation for one or two kind of backbone routers. Well, thank you very much for your if there is any question, I will be happy to receive your feedback. Thank you again.